All right, so let's do some examples. Do some stuff. So our first problem is going to be two vectors or two forces of 32 newtons and 48 newtons. N is for newtons. Measurement of force, a unit of force. Act on a point in a plane. If the angle between those is 76 degrees. Find the magnitude of the resultant force. Just for fun fact, a newton is approximately 0.225 pounds. Not necessary in this problem though. They're related to joules. Newtons are used in, I think a joule is a newton meter or newton per meter or. So we can pick any two vectors we want. I'm gonna call the big one downward. I'm gonna call it 48 newtons downward. And if I wanted 76 degrees, like that would be 90, so maybe that's 76. We'll call this 32 degrees or 32 newtons. And if I were to do that, if I made like an invisible parallelogram, I can see what's going to happen. This is going to be our resultant vector. So how can I find, this is what I want to find, let's call this C. We'll call this vector A, call that vector B, and we got a vector C. Notice I don't have like the X and Y coordinates of these, so I can't really do anything with it as it is. I could make coordinates off of this using straight downward, but there I just fabricated the direction. I chose that. So instead, let's look at what we can do. We know about parallelograms. Right, you treat this as a parallelogram. That was 76 degrees. Opposite angles are equal. And opposite sides are equal. What does that tell me about the other two angles? So like if I call this theta, this is gonna be theta. Theta plus 76 needs to equal 180. So theta equals 104. Now what we're wanting to do with this is find this angle down the middle. Or not angle, but this line down the middle. So I'm gonna redraw that with it as one of the triangles. I've rotated a little bit. And I've made one side look longer than the other. That's fucking fair. But that's fine. Well, the one side should be longer. Let's do this. So this was my A, which was 48 newtons. This was my B, which was 32 newtons. And I have an angle of 104 right here. And I want side C. So I have a side angle side. But I don't have either of these two angles, right? I do not assume that it cuts it in half. The only time this cuts it in half, if A or B are in equal lengths. If A and B are not equal lengths, this doesn't, this bisecting line does not cut 76 in half. Okay, they are not equal. Okay, so we can't assume that. So law of sines is not gonna help us. Because we don't know what this is, we don't know what this is. So we're gonna use law of cosines. So I wanna use the length of A. When we show the magnitude of a vector. They usually show it as doing the absolute value. It looks like the absolute value. But the magnitude of A is 48. The magnitude of B is 32. Newtons. N. So what I'm wanting to find is I want magnitude of C. That's what we're trying to find, the length of C. I guess what I have listed here are magnitudes. Well, law of cosines was the one we have, we're looking for C, so we're gonna say magnitude of C squared equals magnitude of A squared plus magnitude of B squared minus 2 magnitude of A, magnitude of B, cosine an angle between them. And we'll start filling in shit. This is 48 squared plus 32 squared minus 2 times 48 times 32 times cosine of 104. I didn't pull out my calculator, but this is what I have written in my notes. Tell me if that's something you get when you calculate that. That's the squared part. So if we take the square root, I get 63.80583.095. I would say C is about 64 newtons. Since my two initial vectors were in full integer values. I'm sorry, what?
That's the answer to the question.
Yeah, it's the magnitude, it doesn't tell us direction, it just tells us magnitude. In the next problem, we'll look at finding the direction too. Well, kind of hard if I make up which direction I'm pointing at in the beginning. I could have made these triangles, these arrow vectors point any direction. As long as the angle between them is 76. Alright, so next idea. Before we delve into the example, is the equilibriant. The equilibriant is the opposite of the resultant vectors. So if the resultant vector is u, this would be negative u. Find the magnitude of the equilibriant. Forces. 54 newtons and 42 newtons. Acting on a point A. With a 98 degree angle between them. Then find the angle it makes with vector A. Well, B, I want to go off the 42 degree or 42 newton vector. So pictorially what I've got. 98 degrees is bigger than like a right angle, so it's kind of like that. And if I call this the 42 Newton one. And this is my, we'll call this A. That's my 54 Newton one. This is off point A. That's kind of like A plus B. Which means my resultant vector is, or the equilibrium vector. Is the same magnitude going the other way. U equals negative A plus B. And we want the length of it and this angle right here. Let's call that angle theta. The other piece of information we have is this is 98 degrees. Okay, so, let's see, let's make that. Helps to draw the shape. So this is 98, which makes this 98. This is 54, this is 54. This is 42, this is 42. We need this, which is C. Which mean, and I called this B and I called this A. Which means we're gonna need that log cosines again off of this. I called that theta, I'm gonna call this a different one, we'll call that. Is that psi? I think that's psi. It's a fun angle, it's a Greek letter. So again, we're doing C squared equals magnitude of A squared plus magnitude of B squared. Minus 2 magnitude of A, magnitude of B, cosine of theta. A squared is 54 squared plus 42 squared. Minus 2 times 54 times 42 times cosine, oh shit, I don't have theta or psi yet. I need to get that figured out, I think that's psi. Phi, it's phi. Phi. So phi is 180 minus 98. How much is it? 82 degrees. So we'll throw my 82 in right here. I hate rounding to 2. When it's that close to being right down the middle. But significant digits are significant digits. Now I'm gonna redraw this where I've got a little bit more information, right? I'm gonna use the fold C. Well, let's do 63.63. Since I'm gonna use it to calculate my other stuff. This was 82 degrees. And we're looking for this angle here, theta. If I use this angle here, let's go with beta on that one. Theta plus beta. Theta plus beta is 180. So if I find beta, I can find theta kind of easy. But now I have access to the easier formula that we've gone over, log signs. I want this, I want sine of beta over 54 equals sine of 82 over 63.63. Sine of beta is 54 over 63.63 sine of 82, which is so that equals 0.84. Which means beta equals sine inverse of that. 57.2 degrees. So that's this angle, 57.2 degrees. Which means theta is 180 minus that. 0.8. Notice beta is not equal to 1/2 of the 98 degrees that we started with. You cannot just cut it in half and assume you get it. We found beta to be 57.2. And 1/2 of 98 is 49. They are not the same. You can't just cut the angle in half. Yeah.
Can you find the magnitude of the scoring range, the first part of the question, the problem yet? It would be like negative C?
It's gonna be, but a length is still positive,
Okay, like.
so it should, it's the same thing.
Okay.
That's a good question. So I did do C, but the magnitude of the equilibrium. This is the magnitude of result. But that equals the magnitude of the equilibrium. Because it's a length. And lengths are positive. So just because we say it's the negative vector, the negative is more on the angles rather than on the length. Are you guys ready? So next example, and this is one that Keith was fucking pestering me about on Saturday. Despite us not having covered this lecture yet. So let's find the force. Required. Keep a 2,500 pound car. Parked on a hill. That has an incline of 12 degrees. So a picture really helps this a lot. 12 degrees isn't very steep. But it's steep enough. The 2,500 pounds is pointed this direction. It's based on gravity and gravity's down. Really inward, but we picture it as downward. Now, if I didn't have the parking brake on, what direction does this car want to go? If I didn't have the parking brake on, it would roll this way. Let's call that vector V. Or W. If I want to make it so it doesn't move, I need to counteract that vector. Which means I need a force that is pushing equal and opposite this direction. Such that W plus negative W equals 0, and the car doesn't move. Which really means we need to find. Fucking attach a fucking jet engine in this motherfucker? Holy shit. Wonder if the chem lab blew something up and they're just fucking turning on all the fans or something. They're out there fucking cooking meth or some shit, Breaking Bad. Keep our eye on Miss Rodriguez. Miss or Mrs. I don't know. Professor Rodriguez, there we go. Alright, so, something that will help us with this is the idea of parallel lines and transversal lines. I should have done this first. If I have two parallel lines and a line that just goes right through both, these are parallel. This is called the transversal line. It just crosses both. It does not need to make a right angle. It can go at any angle. But opposite interior angles are equal. So if I call this angle alpha, then this is angle alpha. But since they're parallel, this is angle alpha. And that makes this angle alpha. And I could do this as beta, where beta is 180 minus alpha. But that's a lot to write in a small area. I'm just gonna call these angle beta. They either call these opposite interior angles or alternate interior angles. That does not look like the word alternate. So with that in mind, I'm gonna redraw this incline. And here's my car. I don't even know if I need that here. This is 12 degrees, this is a right angle, because I made it into a right triangle, right? What does that make this angle here?
90 minus 12.
78, yeah. Something I'm gonna show you that comes from physics. This force from gravity. Is directly downward like I have listed. It is a resultant vector from the way the car wants to move. And a vector like this. I'm gonna call that U. The gravity force is U plus W. Where the car is like this. That force U makes a right angle right there. And then the gravity force is straight downward. Let's call that F. Again, that's not important to this problem, but it is handy to know. Because if I treat this like that, then this angle here is 12 degrees also. And I can make a thing like that where that's the right angle and this is the 78 degrees. The only reason I bring it up is because this triangle is the one that's easy to work with, because we need this length right here. This length right here. That was our 2,500 pounds. We need that somewhere in our triangle. And my other triangle didn't have that. But if I do this, I make this a right angle here, like shown here, then if this is 78, that makes this a right angle here, and it helps me show that this is 12 degrees. Again, this is like the idea of the alternate interior. But it looks kind of funny the way I have it. And I want this, which is the same thing as this. That's my W. So, what do we got here? I've got our, with getting rid of all the fancy shit. That's 12 degrees, that's 78 degrees. This is 2,500, and that's W. Just making it a triangle where it's easier to like look at. How do I find W?
You do long signs, please.
I could, but there's something even easier than that.
Pythagorean,
What?
the Pythagorean.
Oh, no.
Yeah.
It's just like, this is like SOHCAHTOA here.
Ah, something, there it is.
Like, we could do law of sines here. Law of sines would be W over sine 12 equals 2,500 over sine 90. That does work. So you'll notice if you do this, this would end up being W over 2,500 equals sine 12, because this is 1. And this is the SOHCAHTOA. Opposite over hypotenuse. So like if law of sines is what pops in your head, use law of sines, but you gotta make sure you're using the 90-degree angle to go with the thing here. But if we get it down to W equals 2,500 pounds times sine of 12 degrees. This is really the magnitude of W. W is approximately 53 pounds of force. And it needs to be uphill to stop the car from going down. Alright, there's a couple more examples I want to do in this section, but we ran out of time. I will do them on Wednesday before we start 8.4. I already did some of the 8.4 topics, showing you guys how like the vector with the x and y components. So we started 8.4 as well. Hopefully we'll get all of that finished by Wednesday. If not, we'll play catch up somewhere. Have a good day. I'll see you guys on Wednesday. TTFO.
All right, see you later, Professor Jones, peace.
See ya.